Hello everyone, you are welcome to this video lecture. I'm here to present video lecture 6 on pavement construction. This is a continuation of the previous lecture, which is video lecture 5. As we have said, this lecture is the continuation of physical property test of bitumen, which have been discussed in our previous video lecture, which includes penetration test, softening point test, and ductility test. In this video lecture, the following physical tests are going to be included, which are viscosity test, specific gravity test, and aging test. Now, let us start with viscosity test. Asphalt viscosity is a crucial property that determines the flow characteristics of material at different temperature. The viscosity test involves heating the asphalt sample to a specific temperature and measuring the force required to the sample to flow through a narrow tube, which is called viscometer. The viscosity reading indicates the resistance of the asphalt to flow, with higher viscosity value indicates thicker and more viscous asphalt. By conducting viscosity tests at various temperatures, engineers can determine the optimal temperature at which the asphalt will flow most efficiently, and ensuring the durability and performance of the material in real-world application. Before getting into the procedure, let us see the equipment used for measuring or determining the viscosity of asphalt. This is the equipment used to measure or determine the viscosity, which is absolute viscosity, and this is the vacuum system. And we use this equipment for determining the viscosity, which is absolute viscosity of bitumen. Now we can proceed to the procedure. The procedure will start from sample preparation, and this is the procedure for sample preparation. In this case, first take the bitumen sample in a beaker and heat it to a temperature not more than 60 degrees centigrade for tars and pitches, while the temperature should not exceed 90 degrees centigrade for bitumen, and allow the bitumen to melt at slightly above the softening point of the material until it achieves a pouring consistency. Second, pour 20 milliliter of melted asphalt or bitumen in a suitable container and maintain it to a temperature of 135 degrees centigrade with plus or minus 5 degrees centigrade tolerance. Stir the bituminous material occasionally so that local heating can be avoided. Also, the interrupted air can also escape in this while. 4. Charge the viscometer. For charging, pour the prepared sample into the cup within plus or minus 2 mm of the fill line. 5th, place the viscometer into a vase or oven after charging and maintaining it to 135 plus or minus 5.5 degrees centigrade, and maintain this temperature for 10 plus or minus 2 minutes to facilitate the escape of air bubble. Now we can proceed to the procedure for testing specimen. In this case, first maintain the temperature of the vase at 135 degrees centigrade as it has done previously. However, tolerance is reduced from 5.5 degrees centigrade to 1.0 degrees centigrade. Second, place the charged viscometer in the water bath vertically with help of a holder. Adjust the depth of the thermometer such that the uppermost timing mark remains a minimum of 2 centimeters below the liquid surface. Third, connect the vacuum system to the viscometer after establishing a vacuum of 30 plus or minus 0.05 centimeter of mercury and keep the valve of the vacuum system closed. As we have said, this is the vacuum system and the vacuum chest system should be connected to the viscometer. Viscometer. 6. Measure the time required for the leading edge of the meniscus to pass between the two consecutive pairs of the timing mark in seconds. Accuracy of 0.5 second is required. Now we can proceed to the specific gravity test. Specific gravity of bitumen refers to the ratio of the density of bitumen to the density of water with equal volume at specified temperature. It is an important property that helps in assessing the quality and performance of bitumen in various applications such as road construction. And the objective of specific gravity test is to determine the specific gravity of bitumen using a specific gravity bottle and water. The materials required for conducting viscosity tests are 1. Bitumen sample, 2. Specific gravity bottle, 3. Water, distilled water, 4. Thermometer, 5. Balance, 6. Hot plate, 7. Tongs, 8. Beaker, 9. Steering rod. Before getting into the procedure, let us see the apparatus which is used for measuring or determining the specific gravity, which is known as specific gravity bottle. Here, first, we weight the empty specific gravity bottle and register as W1. And then fill the specific gravity bottle with water, with distilled water, and measure the weight, which is recorded as W2. After pouring the water, we fill the specific gravity bottle with bitumen up to the mark shown on the specific gravity bottle, and the weight is registered as W3. And this is a specific gravity bottle after immersing the specific gravity bottle in the base, and the weight is registered as W4. Now we can proceed to the procedure. The procedure is similar to the procedure that has been seen here in this figure. First, weight the empty specific gravity bottle accurately using the balance and record the weight as W1. This is W1. Second, fill the specific gravity bottle with distilled water at a constant temperature, usually 27 degrees centigrade, up to the mark, and weight it again, record the weight as W2. This is W2 after we fill with distilled water. Third, empty the specific gravity bottle and fill it with the bitumen sample up to the mark and weight it and record the weight as W3. This is the weight recorded as W3. Fourth, place the specific gravity bottle containing the bitumen sample in water at the same constant temperature and heat the water gradually using hot plate while stirring the bottle inside the specific gravity bottle until all air bubbles are removed. Be careful not to overheat the bitumen. Fifth, once the temperature is stabilized, record the temperature reading with thermometer as T1. Seventh, remove the specific gravity bottle from the water using tongs and allow it to cool down to room temperature. Eighth, weight the specific gravity bottle containing the bitumen sample and record the weight as W4. This is the weight W4. Ninth, calculate the specific gravity of the bitumen using the following formula. This is a formula to calculate the specific gravity from the registered or recorded weights. While we are conducting this specific gravity test, we have to take care for our safety. So we have to use this safety precaution. Handle hot material with caution to avoid burns. And use tongs to handle specific gravity bottle to prevent any accident. In conclusion, based on the specific gravity value obtained, we can determine the density of the bitumen sample, which is crucial for various applications in the construction industry. Now we can proceed to the next physical test of bitumen, which is aging test. One of the key methods used to assess asphalt aging is rolling thin film oven test, or RTFOT. This test simulates the aging process by subjecting the asphalt sample to high temperature and airflow, and this replicates the effect of prolonged exposure to the sun and air. Through the RTFOT test, researchers can measure change in the asphalt physical property, such as stiffness, viscosity, and durability. These measures provide valuable insight to the aging effect of the overall quality of the asphalt. In addition, in addition to the RTFOT test, other methods such as thin film oven test (TFOT) and pressure edge vessel (PAV tests are used to further evaluate the aging characteristics of asphalt. By combining these tests, researchers can develop strategies to enhance the longevity and performance of asphalt in road construction. Now let's see the details of the rolling thin film oven test. The rolling thin film oven test, or RTFO test, is used to evaluate the resistance of an asphalt binder to rotting at high temperature. Rotting is the permanent deformation or groove formation in the asphalt pavements caused by traffic load. In the RTFO test, a thin film of the asphalt binder is created and exposed to heat and pressure. She is simulating the conditions that the asphalt pavement will face on the road. The test measures the viscosity and the binder, its ability to resist deformation under this condition. In conclusion, asphalt aging tests play a crucial role in ensuring the durability and reliability of roads. By continuously innovating testing method and materials, we can pave the way for safer and more suitable infrastructure for the future. The technicians carefully load the asphalt binder sample into the RTFO test equipment and set the parameter for temperature and pressure. The equipment then applies in rolling motion to the sample, mimicking the stress of traffic loads on the pavement. This is the equipment used for conducting rolling thin film oven test. We put the sample here and rotate at constant rate and specific temperature. Once the test is completed, the results are analyzed to determine the routing resistance of the asphalt binder. This information is critical for engineers and contractors to select the right type of asphalt mix for the specified road construction project. Let us proceed to the procedure. The procedure for rolling film oven test. Step 1. Sample preparation. Start by selecting a representative sample of the asphalt binder or mixture that you want to test, and then prepare the sample by ensuring it is clean and free from any contaminants. And then cut the sample into small pieces of pellets for testing. Step 2. Loading the sample. Place the prepared sample into the rolling film oven test apparatus, and then make sure that the sample is evenly distributed on the roller to ensure uniform heating and aging. Step 3. Setting parameters. Setting parameters. Set the temperature and rolling speed on the rolling film oven test apparatus as per the testing standard or specification. And then the typical temperature range for the test is between 163 degrees centigrade to 177 degrees centigrade. And the rolling speed is usually around 2 to 5 revolution per minute for 85 minutes. Step 4. Aging process. Being the aging process Begin the aging process by starting the oven and allowing the sample to roll at the specified temperature and speed. The sample will be subjected to continuous rolling and high temperature to simulate the aging process that asphalt and binder and mixture undergoes in the field. Step 5. Step 5. Monitoring. Monitor the sample closely during the test to observe any change in the physical properties such as viscosity, stiffness, and color. Record any changes or observations during the aging process for analysis and comparison. Step 6. Cooling and analysis. Once the desired aging period is completed, stop the rolling and allow the sample to cool down, and then remove the sample from the apparatus and conduct further tests or analysis to evaluate the effect of aging on the asphalt binder or mixture. Rolling thin film oven test is an important test for bituminous because it simulates the aging effect that bitumen undergoes due to exposure to heat and air during the construction and service life of the asphalt pavement. The rolling thin film oven test should be conducted for different purposes. This test helps to predict the performance of bitumen in terms of durability and resistance to crack and rotting. By subjecting bitumen to high temperature and airflow in the RTFO test, it allows for the evaluation of how well the bitumen will perform over time, and providing valuable information for the selection of appropriate bitumen for road construction. This is all about today. Thank you for your attention.